Good afternoon, boys and girls. As promised, we will start with your syllabus today. I will give you a few more questions to do when I go home. Now, we are going to start with the first basic chapter of physics, which is units and measurement. In this lesson, we will teach you to derive or obtain the units of all quantities in the subject. There would be some quantities which you have heard of, and there would be some new quantities which will unfold in front of you in these 2 years. So please don't bother if you do not understand a particular quantity. In this lesson, we are just to learn to derive its units. The chapter will unfold in front of you as we discuss the topic. Be sure that you make your own notes. There have been people who have been asking me, sir, what about the study material? Remember, whether it is lockdown time or not, we do not supply study material. You make it yourselves. That is the way I work. We work rather. Units and measurements. First of all, we ought to learn that what do we mean by a physical quantity? You know, anything that can be measured is called a physical quantity. The basic laws of physics, the basic laws of physics are expressed in terms of measurable entities. Entity is also some quantity only, We can study the laws of physics in terms of mass, length, time, force, electric field, charge. There are so many other things, And all these quantities which can be measured are called a physical quantity. Are called a physical quantity. To measure a physical quantity, we ought to know two things. One is, okay, I'll give you an example first. The length of this room, it could be 10 meters. It means first of all you chose a unit. We all know how much is 1 meter, around this much. This is 1 meter, okay? And that 1 meter is contained 10 times in this room. Whenever you measure a physical quantity, you must first of all select a proper unit for its measurement. If you choose the unit to be centimeter, which we know is around this much, then in the same room, the number of times that 1 centimeter would be contained is different. I hope you understand. You can also choose a millimeter, but that would be absurd. We need to choose a proper unit for its measurement, like distance from Patiala to Chandigarh. Okay, 75 kilometers. So you very reasonably chose kilometers as the unit. We all have a basic idea about what 1 kilometer is. And that 1 kilometer is contained 75 times in that distance. The mass of the book is 2.5 kilogram. It means you have chosen 1 kilogram to be the unit. We all know what 1 kilogram is. And that 1 kilogram is 2.5 times in this book. So whenever we need to measure a physical quantity, it should be clear that first of all we will select a proper unit for its measurement, and then we should know the number of times that unit is contained in that physical quantity. Unit. How do we define a unit? It is the, you should make the notes right away. Yeah? It is the standard of measurement of a physical quantity. I hope it makes sense to you. It is the standard of measurement of a physical quantity. By standard, we mean that it will be the same everywhere. Whether you measure it in India also, it is a big country, you know, Bombay, Jammu and Kashmir, Kanyakumari. You can even go around the world. You go to Timbuktu, yeah, there's no problem. The unit would be the same. World over, everybody knows how much is 1 meter and how much is 1 centimeter. They could pronounce it in a different manner, but it is the standard. Let Q be a physical quantity. To be measured. Let U1 be unit selected for its measurement. And N1 is the number of times that unit is contained in the physical quantity. If U2 is the unit selected, if U2 is the unit selected for the measurement of the same quantity, this unit could be different. Okay, another unit. Then the number of times this unit will be contained will also be different. We all know that 1 meter has 100 centimeters. Thus, if something is 2 meters, it can be 200 centimeters. It's the same thing. If you change the unit of the physical quantity, then the number of times the new unit would be contained would also be different. If the unit is larger, the number of times that larger unit is contained in the same physical quantity would be smaller. And the reverse is also true. N2 is the number of times this unit is contained in the physical quantity. Clearly, Q is equal to N1 U1 is equal to N2 U2. There's nothing to cram here, you know. If we select the unit as U1, say meter, then the number of times that meter is contained in a room is say 5 meters. This means that 1 meter is contained 5 times. If you change the unit to centimeter, centimeter is the smaller unit selected for the measurement of the same physical quantity. Then the smaller unit is contained 500 times as 1 meter contains 100 centimeters. The quantity is the same. Therefore, N1 U1 is equal to N2 U2. Clearly, if U2 is less than U1, then N2 would be greater than N1 and vice versa. This is the first thing that we have learned today. You know, something very interesting, that why was it required? Why was it required that we have a unit for the measurement of a physical quantity? In the earlier times, I'm talking about the old Stone Age, you know, there used to be something called the barter system. In the barter system, they used to say, okay, I will give you some fire. Fire used to be exchanged, you know, in those times. And, okay, you give me some tomatoes, let's say. Or you give me one thing, I'll give you another. But that started up with fights, you know. Things could say that your tomatoes were not good. Somebody could say the potatoes you bartered for were not okay. And this barter system was not an efficient system to trade between places. There were no countries, Then they started measuring it by your foot. Now, some people have smaller foot, some have larger foot, or they used to measure it like this. But then, as the trade grew all over the world, then they said that this is not the right way. There should be some standard to measure physical quantities, because every country is not enough for its own needs. We need to move around here and there or trade places. One thing grows at one place, another thing grows better at one place, and so on. Thus, that is why a standard was required, which is accepted all over the world. Now, there are some quantities which are called, there are some quantities which are called fundamental quantities or basic quantities. Those quantities in mechanics, in the study of mechanics, we divide something into mechanics, electricity, magnetism, optics, nuclear. But let's talk about mechanics only because that makes a lot of sense to you also. When we talk about basic quantities are mass, length, and time in mechanics. Why do I call them basic quantities? Because all quantities in mechanics can be expressed in terms of these quantities. And these quantities cannot be expressed in terms of other quantities. Other quantities can be expressed in terms of these. Like, you say some quantity, any quantity in mechanics, volume, length into breadth into height, right? Length is obviously length, breadth is also some kind of length only. Anything which has a unit of meter or centimeter will be fundamentally called length. So, volume can be expressed in terms of length 3 times. Area, length 2 times. Say anything else. Density, mass upon volume. Mass, volume we know is length. Speed, distance over time. Some kind of a length upon time. Acceleration, speed upon time. Speed is length upon time, upon another time. Whatever quantity you say in mechanics, it can be reduced to mass, length and time. That is why, as science progressed, we first of all had the foot-pound-second system of units. And the name of the system is obtained from mass, length and time. See, foot, the unit of length. Pound. Mass used to be earlier measured in pounds. To date, and the weight, the mass of a newborn baby is in pounds. System of units. FPS. The foot-pound-second system. Foot-pound-second. This has become obsolete. Obsolete means we rarely use it. We do not use it any further. You will not get any numerical problems regarding foot-pound-second system. Then we have the CGS, which is the centimeter, gram and second system. Then we have MKS, which is meter, kilogram and second. This is the system which is prevalent. CGS is also used, but we know how to convert CGS into MKS. I will also teach you. We extended. Now, MKS would contain quantities in mechanics only. There is another system which is called SI. This is the international system of units. It's simply called SI. The word system, the S is already there. SI. It is actually Systematica di Internationale. I repeat, it is Systematica di Internationale, which is, that's French, you know. It's International System of Units. This is an extension of MPS. Contains basic quantities and their units, which span the entire subject. We have 7 such quantities. It's so wonderful, you know, it's really so wonderful that we can express any quantity in the subject just in terms of these 7 quantities. 3 used for mechanics, all 7 combined together for any quantity in the subject. Okay, physical quantity and its unit. Mass. Anything which is mass will be written as square brackets and mass, which will be kilogram. Length, written as square bracket. I'm very bad drawing here. This is length. This is time. This is second. Do not write SEC. That means secant theta or something, you know. We can write simply S or completely secant. Anything else, please? Anybody who remembers? Come on. Amount of substance. MOL. And this is in mole. Current. Okay, electric current. I. It could be A also. And the unit is ampere. What else? Absolute temperature. This is 1, 2, 3, 4, 5, 6. Absolute temperature. Square bracket K. And the units are Kelvin. And 7th we have luminous intensity. Candela, from candle. These are 7 major units. These are 7 major units. We have 2 subsidiary units. Number 1, angle. Its unit is radian. Solid angle. Its unit would be steradian. It is an angle in 3 dimensions. Solid angle is an angle in 3 dimensions. Like in an ice cream cone, the angle formed is in air. Thus, angle is on a plane surface, you know. Solid angle is angle inside a cone. I hope you get it. The units are radian and sterradian respectively. So these are, just imagine, we will just do it. Let's hope we start today or tomorrow would be fine. That we have 7 quantities in the subject which are used to express any quantity in the subject. It is completely mesmerizing. Now, let us see that what are these basic quantities? Basic or fundamental quantities. Basic or fundamental quantities. Quantities such as mass, length, and time for mechanics, and other quantities in SI are called basic quantities. Why? Any other quantity can be expressed in terms of these. These quantities cannot be expressed in terms of any other quantity or between themselves. These quantities cannot be expressed in terms of any other quantity or among themselves. Or other quantities. Acha. And the units of these quantities would be called basic or fundamental units. Units of these quantities are called basic or fundamental units. Let's quickly analyze derived quantities and derived units. You can write there also, basic or fundamental quantities and fundamental units. Those quantities, you can write it down side by side in your notebooks, just as if it was a classroom. Make it a real classroom. Sit down on a chair and a table and see to it that after the lectures your notes are complete. Then read them again and see if I have given someone a medical problem. It will be there on the group. Please see that you are making your own notes and be proud of them. Those quantities which can be obtained or derived And the units that can be obtained from the units, from fundamental units. Simple. Let's keep it simple. The units that can be obtained from fundamental units are called derived units. Like speed, it is a derived quantity. It has been obtained by length upon time. Length and time are basic quantities, as speed has been expressed in terms of length and time. Force, mass into acceleration. Acceleration is speed upon time. Speed is distance over time. So ultimately it is going to reduce to mass, length and time, and you cannot reduce it further. All these quantities can be expressed in terms of mass, length and time. They are called derived quantities for mechanics. For other things, we will use any quantity contained in the international system of units. So speed becomes a derived quantity and its unit, meter per second, becomes a derived unit. Like the unit of force, you would say it is Newton. I would say no. It is right, it is not wrong. But I would say it is kg meter per second square, which we have called 1 Newton so that the new generation remembers famous names. So that becomes a derived unit. The units of derived quantities. If derived quantities are obtained from basic quantities, derived units will be obtained from basic units. So please keep writing, and you will write it only once. Then these will be yours. They are your notes that you are making. Let me see how much time has elapsed. Okay, we can work with some more time. What are the coherent system of units? It is not a new system of units. The system of units are FPS, CGS, MKS and international. We have to see that which of these system of units is coherent. For that we must know the meaning of the word coherent system of units. A system of units is said to be coherent. A system of units is said to be coherent if it contains a certain set of units by the multiplication and division of which we can obtain the units of any quantity in the subject. Okay, let's put it down. A system of units is said to be coherent if it contains a certain set of units by the multiplication or division of which we can obtain the unit of any physical quantity in the subject. So what do you think, which of the systems is coherent? It is obviously SI, because CGS in case contains only those quantities which deals with mechanics. The international system of units deals with so many quantities by the multiplication and division of which we will be able to obtain the units of any physical quantity in the subject. Example, SI is coherent. Boys and girls, parents, students, boys and girls keep on asking me, sir, which book do you have to follow? Have you seen this situation? What happens at the book market? I think we all know. Boys and girls, you do not need a book. In my entire teaching, we have never used a book. When you will come physically, we will definitely ask you to keep a book, but on your tables at home. Whatever work I'm going to do over here is going to be in your registers. It's going to be on the board. Whatever work I'm going to give you will be from the book. For that, presently I'm scanning the questions and putting them on the group. And you can ask me your doubts, if any. If the doubts would be common and numerous, I will make a small lecture for it, as I'm doing with plus 2 classes. When we start with plus 1, it really takes some time, well, almost a month, to put ourselves on track. But please see, students, that if you think that you will study on the last days or just before the test, then you're going to have it. It could be valid in your classes 8th and 9th, but here it is the regular process which is going to. Have you ever wondered that if you have a leaking tap, you just hear one drop of water falling at night. Tip, tip. You just ignore it. Be sure about it. When you go in the morning, you will see the bucket full. You will see the bucket full, that drop by drop by drop. And you must have heard of stalactites and stalagmites, where a drop of water comes, freezes, drop of water comes, freezes, ultimately becomes unbreakable. We are going to become one of that. Be sure that we are studying every day. It's just a little amount of work every day. Now what was I going to discuss, Okay. We have something called constants and variables. We have something called constants and variables. There are some quantities in physics which are constants, and there are some quantities in physics which are variable. Variable means they can have any value, like speed, velocity, acceleration, force, momentum. They can have any value. But there are some things which are constants, like velocity of light in vacuum, gravitational constant, Planck's constant, Avogadro number. There are some quantities which are constants. Up to your junior classes, you were having something called unit, which is very important. Like if I say 5, what the hell is 5 here? Is it, what are you measuring? But once I say 5 kg, you will come to know that we are measuring mass, and you have chosen the unit, the standard, to be kg. If I say 20 kilometers, obviously, I think you get my point. But another factor which is going to be here is going to be dimension. Now, what do they mean by dimension? give you an example. Let me say speed. Speed is length over time. I can write it as length upon time. And this will be LT minus 1. Okay, another example. Force. I can write only the mass into acceleration. Mass into velocity upon time. Mass into velocity is length over time. This is mass. This is length over time. And there is another time. I can write it as M L T minus 2. I hope you understand what I am doing. Okay, it could be momentum. M into V. V is speed or velocity. Yeah? M and V is LT minus 1. And so on. Speed can be expressed once in terms of length. We need not put 1. And minus 1 times time. Force can be expressed in terms of 1, the power, power. Mass is power 1, length is power 1, and time is power minus 2. Momentum is 1 for mass, 1 for length, and minus 1 for time. This power is called dimension. This power is called dimension. Thus, dimensions are the powers. Dimensions are the powers to which the fundamental quantities of mass, length, and time have to be raised. They are the powers to which the fundamental quantities are to be raised. Not necessarily mass, length, time. There will be ampere, candela, and Kelvin also, They are the powers to which, okay, let's write it down. Dimensions are the powers to which the fundamental quantities have to be raised to express the unit of a physical quantity. They are the powers to which in physics it is going to be very less that you are going to be asked the definition for dimensions. It is for you to understand. We are going to ask application. More of application, less of cramming. So thus you should understand what do we mean by dimensions. We can also do it in Hindi or Punjabi. But we should know what do we mean by dimension. Whenever we need to express the unit of a physical quantity, we need to write it in terms of fundamental quantities, and we have to raise to the power. It is this power which is called dimension. Okay. Dimensional formula. Dimensional formula. How many quantities did we require to express speed? 2. Length and time. Force, we required mass, length and time. Momentum, mass, length and time. Thus, a dimensional formula, boys and girls, this is the dimensional formula for speed. This is the dimensional formula No need to put it in a box. I'm just highlighting here. And this is the dimensional formula for momentum. Dimensional formula is an expression. It is an expression showing how and which of the fundamental quantities are required and how are they required. An expression showing how and which of the fundamental quantities are required to express the unit of a physical quantity. Right? Dimensional formula, an expression showing how and which, like area, only length is required. Volume, only length is required. Density, mass to volume, we require mass and length. Mass once, length minus 3 times. Let's see what is a dimensional equation. Dimensional equation. When we write that speed is equal to speed is equal to LT minus 1. When we equate the dimensional formula to the physical quantity, it is called a dimensional equation. Force equal to MLT minus 2. This is the dimensional equation. Right? An equation obtained by equating the dimensional formula to its physical quantity. Thus, if I write force equal to MLT minus 2, then these powers they are called dimensions. This expression here is called, here let's do the reverse, right? This is a dimensional formula, and this here is a dimensional equation. I have summarized it. It is not necessary that you remember the exact expression, but you should definitely know what it is. If we are able to do a few of them in our heads, so that we don't always, initially you can, like speed, meters per second, or distance upon time, length upon time, L t minus 1. Speed of velocity is the same. Acceleration, speed upon time. Speed was L upon time, another time, LT minus 2. Acceleration is LT minus 2. Force, mass into acceleration, M directly LT minus 2. You can do it directly. There would be some quantities which we always will have to derive, but it would be convenient if we remember a few of them. Today I have talked to you about dimensions, dimensional equation and dimensional formula. What is a physical quantity? What is the system of units? N1, U1 is equal to N2, U2. Please see that you revise this much of your work. Have a good day.